Hello, everyone. Again, it is Mr. Hine. Today, talking to you about exponents and how those work. So, before we begin, if this is your first time doing math today, take a deep breath to just focus in and be ready to just focus on math and try to tune out all of the other distractions around us. All right. So, be aware of whatever you're thinking about. Take that focus of yours and then focus it in on the breath. So for example, I'm thinking about lunch because I'm pretty hungry, but I'm going to just listen to my breath. All right. So here you go. Breathe in and out. And if you feel your brain wandering, that's okay. Just bring it back to the breath. In and out. And through the nose only, in and out. Okay. So here we go. Exponents. Now, in the beginning, we're just going to talk about how they work. And then later in this video, I'll talk about some shortcuts. Okay. So let's first just talk about how they work. So exponents is, say you have and I just like to work it through examples with you. So say you had something like 3 to the second. This little number up here, that's called the exponent. And if positive, which it should be, that's how many times you're multiplying the base number. And this is the base number. So 3 to the second is equivalent to 3 times 3. You multiply it 2 times. And 3 times 3 is 9. Right. So that's how exponents kind of work. Now we're going to do some examples that get more abstract where you actually don't have to, there's not much you can do because it's just with letters. So for the first one, let's look at, say, x to the third times x to the fourth. And let's see what that gives you. So rewrite this out. This right here means x times x times x. That's what this means. And this means x times x times x times x. It means that you're multiplying that, whatever number that is, 4 times. And then we're multiplying both of these two things together. Well, notice that when we do this, how many times are we actually multiplying this same number? 1, 2, 3, 4, 5, 6, 7. So we could actually write this as x to the 7th. And that's a simplified answer of your original problem. To go one more example, say it was x to the second, or let's not even use x. Let's say we did y to the second times y to the fourth. Well, this means that times itself 2 times. This means you multiply by itself 4 times. We're multiplying these two expressions together. Well, how many are there total? 1, 2, 3, 4, 5, 6. So we could actually just write y to the 6th. Okay. So there's some examples there. What should I do next? What about, so that's multiplication. What about division? What if I did x to the 5th divided by, remember that means division, x to the 3rd. So if I write this out, this on top means that you're multiplying by x 5 times. So 1, 2, 3, 4, 5. And on bottom, there'd be 3. 1, 2, 3. Now there's a trick when dividing here, and that is I'm going to line these up. So the top we'll just write the same way. But on bottom, these 3 x's, I'm going to line them up. So I'm going to put that x underneath that x underneath that x, and that x underneath that x. And then you can always multiply by 1, and I'm going to fill in 1s forever else. Because if you multiply by 1, that doesn't change anything. 5 times 1 is still 5. Right, so that you just add in, doesn't change the problem. Now what's happening here is when you line it up, you have x divided by x. We just focus here. And what's anything divided by itself? Like say, for example, note, what's 2 divided by 2? That's 1. What's 5 divided by 5? That's 1. What's, 1,000 divided by 1,000? That's 1. What's Hein divided by Hein? If it's the same thing, that's 1. So this note comes in handy up here because this, since it's the same thing, actually just makes 1. This makes 1. This makes 1 because they're the same. So what you're actually left with is you just have 1 times 1 times 1 times x over 1 times 1. But remember, times 1s don't really do anything, so we can kind of ignore all those, and you're just left with x to the second. And there's your final answer for that problem. I'll show you another one. And again, we'll talk about the shortcuts later if you don't see them yet. But what if you had, let's say, p to the third divided by p to the second. Okay. So if we write this out, on top here, you'd have p times p times p. And on bottom, you'd have p times p. There's 2. Well, if we just rewrite this a little bit, where these two I'm going to line up underneath each other, and now I'm going to fill in a times 1. Well, notice, same thing on top and bottom. That, no matter what number it is going to go to 1. This is going to go to 1. And don't worry if your 1s aren't perfect. Right, and that we can't do anything with. So this becomes 1 times p over 1, which is just 1. Dividing by 1 doesn't do anything, so you're just left with p. Or you could even write, if you're more comfortable, p to the first. If there's no number there, it's always like that invisible 1. Yeah. So that's another one. So, and then the last one I'm going to show you, a different type, is what if you had, say, b to the second, and all of this is in parentheses, and it's raised to the third power. Now, what does this mean? Write it out if you don't know. Well, let's work downwards. This means b times b, and then you still have to the third. And then what does the third mean? It means that there's 3 of these. So then that actually means that there's 3 of those. Right? 1, 2, 3. And if you simplify it, how many are there total? And they're all multiplying here. So you have 1, 2, 3, 4, 5, 6 multiplying. So you can actually just write that as b to the 6th. And then over here, look at another one. Say I did, we'll use g to the 4th raised to the second power. So that means that there's 2 of these. So I could write that g to the 4th times g to the 4th. That's what that means. And I'll write it out still since we're still learning this. That means that there's 4 g's. This means that there's 4 g's. For how many are there total now? 1, 2, 3, 4, 5, 6, 7, 8 multiplying. So you can write g to the 8th. Okay. So there's actually 3 different things I just went over. Up at the top, this is when multiplying. This whole middle section was when dividing. And the very bottom was when you have a power raised to a power. Now there's shortcuts for all of these. And I'm going to kind of say it out loud, and then we'll write it on the back and I'll show you. If you look at the first ones here, where are they? Find on my paper. So multiplication. What's the shortcut? Well, notice when you did 3 x to the third times x to the fourth, the answer is x to the seventh. How can you get that without doing all the work? Well, notice, what did we end up doing? We just ended up doing 3 plus 4, right? We ended up just adding these together. So the trick with multiplication is you can just add the exponents. And I'll show you that on the back. Notice over here, y second times y4. When multiplying, since these are the same, we could just add these. 2 plus 4 gives us 6. All right? So that's the shortcut there. In the middle, what's the shortcut when dividing? Well, we had 5 and 3, and notice that 3 of them went kind of away to 1, and you were just left with 2. So that's like doing 5 minus 3 would give us the 2. Same thing down here, the 3 and 2, well, 2 of them went away, and we were just left with 1, which is the same as saying like 3 minus 2. So when dividing, the shortcut is you can just subtract the exponents. And then the last one, when it's a power raised to a power, what's the shortcut? Is when it was 2 to the third and we got a 6, how do you get 6 from 2 and 3? You can just multiply those two. Same thing over here, 4 and 2, 4 raised to the second, and then we end up getting 8. If you just did 4 times 2, we had 8. So the trick here is you can multiply exponents. So those are your shortcuts. And let's show you them on the back really quick with examples just using the shortcuts. Now, if you don't like these shortcuts, all of this still works, right? Everything here, it works. That's correct. As long as you can get the right answer in my class, that's all that matters. That's what math is. Get an answer, understand the problem, you're fine. Yes, there are better ways, but if you don't need those better ways, then you're all good. So what are the shortcuts to working with exponents? Okay. First one is if you're multiplying with the same base. The shortcut is you can just add the exponents. All right. So example here is if I did 2 to the, no, I'm not even going to use numbers, x to the third times x to the 10th. Same base, multiplying. What do? Just add those together so you get x to the 13th. Whoa, why did it lose so much focus? Sorry. There you go. So recapping, when multiplying with the same base, the shortcut, the base is the same x and x, we can just add 3 plus 10 and get 13. If I did z to the first times z to the fifth times z to the seventh, they're all the same base. I'm multiplying, so I can just add those up. 1 plus 5 plus 7 gives us 13 too. That's just unlucky. I'll make that a 2, so just to get a different answer. 14. Okay. So that's that one. The second one, what if you are dividing with the same base? The shortcut is to subtract the exponents. So if I did a to the fifth divided by a to the second, that's the same as just saying 5 minus 2, keeping the base the same, still a, and that's a to the third. If I did, and we'll use numbers because numbers works the same way, 7 to the fifth over 7 to the third, keep the base, so the 7 stays, and you just do 5 minus 3, which is 2. And that's fine. If you wanted to simplify that, yeah, you could put 49. That's correct too. Won't matter here. And then the third thing is when you do raised to a power. Raised to a power. What you do here is you multiply the exponents. Okay. So you had, say, b to the fifth, all of that raised to the second. You could just do b to the 5 times 2, which is 10. Furthermore, if you had j to the fourth raised to the third, that's the same as just j to the 4 times 3, which is 12. And even with numbers, remember, it doesn't change with numbers. If I did 3 to the fifth raised to the second power, you don't need to use a calculator, not if we're just simplifying. That's the same as 3 to the third, 5 times 3, which is 15. In fact, that's a really large number if you went on a calculator. Okay. So there it is, exponents with shortcuts at the end. So shortcuts on the front is why those make sense, right, where those come from. Whichever method works for you is great. Just find something that makes sense to you and go for it. All right? Come to office hours if needed. This can be a trickier topic. Any topic can be. All right? Bye-bye.